Okay, so we're going to go over the reading that you guys just did and I want to explain things a little bit more based on what you did. So just kind of follow along with me. So we mentioned in this reading that the Earth is more than 4.6 billion years old. So it's hard for us to fathom that on a timeline. So we've only been here just like a tiny blip on the timeline of how long the Earth has been around. So that's an important thing to remember as we start talking about evolution and especially human evolution. So changes have happened over this time gradually, right? That we didn't like notice. It wasn't like a light switch. It didn't just happen. Things have changed over time. So that's important to note. Some terminology that we should know. Adaptation is an important term. We talk about adapting all the time in our everyday lives, but when we talk about it in science, what do we really mean? So it's a characteristic in a living thing that improves its chances of surviving and then reproducing. Okay, so the goal of any living thing is to survive in its environment and reproduce. So don't just think of humans, think of every living thing when we think about adaptations. And then we have to define what a species is. You'll hear us talk about species often. So this is a group of organisms that's very closely related. They have to be able to mate and make more offspring. So when they mate, their offspring have to be able to reproduce. So there are some living things, some animals and such that cannot produce fertile offspring when they mate. So fertile means that their offspring are able to reproduce. So sometimes their offspring cannot, so they would not be technically considered a species. So that's important to note. And then you're going to hear this term evolution quite often. Really what it means is that as we move through that timeline, you see those inherited characteristics within a population change over many generations, right? And then new species sometimes arise from that. So we talk about having a common ancestor and then something probably developing from that common ancestor. So that's important to note. These are kind of subtle changes that eventually are kind of big changes, right? So we're going to talk about a lot of that. And then we, of course, have to have information, right? So when we talk about fossils, this is kind of like putting together the puzzle. It helps us figure out who and what existed when and where, and they get preserved in sedimentary rock. You guys talked a little bit more about that as sixth graders when you're talking about earth science. But we have to study these to put the pieces together about what this all looks like. So that's important. And then we, of course, have this record, right? So it's the historical sequence, and we don't have all the pieces yet. We may never have all the pieces, right? But it's important to note that. And this was a picture that you saw. This is a model, right, that kind of proposes or suggests the relationships between some of the ancient mammals that we used to see and modern ones from today and how connected they are. So they mentioned the whale bone, which I think is a really, really important thing to mention. So there's this ancient ancestor of whales, right? It may have been a mammal that lived on land. Now think about that. Whales we often call fish. Whales are not fish. They are mammals. They have to come up for air. They have lungs and they have mammary glands and all of that. Those are characteristics of mammals. They are not fish. But this ancient ancestor has a very similar connection with current today's whales. So that's really, really interesting to connect, right? So they may have sort of had that development into what is our modern day whale. So this picture kind of shows you more about that, and you can spend some time looking at it more. But there's this little bone, right, that they showed you that really is what they are using to kind of make that connection. And it looks a lot like a leg, right? But obviously whales don't have legs. So this is kind of a neat thing to take a look at. And we'll address that a couple more times. So it's really important to mention this term vestigial structure. So these are remnants of organs in our bodies, living things' bodies that may have at one time had a purpose, right? But we don't have a use for them anymore. So we could probably think, if we wanted to, about vestigial structures in humans, right? So what are some organs that we have that we don't use, right? There's a difference between not needing it, right? We can live without certain organs and parts, but we're saying that they don't have a use today. So we're going to address that a little bit more, but the key is to think about things like your appendix, right? Your appendix can become infected. It can be removed, but it doesn't serve a purpose today. Now, scientists actually recently have made some connections to where the appendix is perhaps an older, humans or previous humans, our ancestors, many moons ago, may have used it in digestion because they may have digested or had to eat food that was much more hard to digest or complicated to digest versus what we eat today. So that's just one theory of what a vestigial structure is. Some other ones which you might be kind of grossed out about, but in utero, or in other words, in development, humans have gill slits. They close. We don't have gills, right? But it does make a connection with perhaps that, again, that evolution from earlier species to today's. And then, of course, we have a tailbone. We know we don't have a tail, right? But at one point we may have, right? Why do we have a tailbone? It doesn't serve a purpose because we don't have a tail. So those are things to kind of think about and kind of be interested in. So we can compare skeletal structures, and this is one of my favorite pictures in your science book, which of course we're just looking at pages right now, but you don't have the book in your hands. But these are the bones of humans, cats, dolphins, and bats. Now you might look at it and go, gee, they're not very similar. But if you highlight the bones that serve the same purposes, they are very, very similar. So it shows again that all of these animals, in this case, may have had a common ancestor, right? One that they all developed differently from. So that is kind of neat to take a look at. And you can see like very similar bones. They might look a little different, but they're all used for the same reasons and ways. So that's kind of a neat picture to take a look at. Okay, we're going to stop there and head back in.